Bandidas, co-coordinator, CMR Technical Campus. We would like to express our sincere thanks to the AICT ATAL Academy for approving the 6-day online AICT-sponsored ATAL Faculty Development Program. It gives me immense pleasure to extend a warm welcome to all of you for 6 days online AICT-sponsored ATAL Faculty Development Program, Advanced AI Tools for IIoT Framework, which is organized by Department of CSE, AI and ML, CMR Technical Campus, Hyderabad. At the outset, I take this opportunity to convey my thanks to the management and our beloved director, Dr. A. Rajareddy sir, Dean R&D, Dr. K. Srijan Raju sir, Dean Academics, Dr. Dharmaji Rao sir, Dean IKC, Dr. G. Srikant sir, and HODs for their continuous guidance, encouragement, and support. I also extend special welcome to the distinguished speakers, faculty, participants, research scholars, and postgraduates joining us from various places across the country. So we have received an excellent response all over the country. Almost all 200 participants from various colleges with 15 different states have registered from this FDP. Initially, we thought whether we crossed almost 200. Now today, the AICT stopped the registrations. Otherwise, it would have touched to 300. The topic which has chosen for the FDP is advanced topic. Very useful to the research scholars, faculty, and also PG students. This 6-day FDP sponsored by ATAL is designed to provide participants with both conceptual clarity and hands-on exposure to various simulation frameworks, software tools, and practical use cases. You may have seen detailed schedule in the group. It is a mixture of theory, use cases, and software tools, etc. We are privileged to have a galaxy of eminent speakers from premier institutes and industries. Absolutely, I am sure that this faculty development program will be helpful for faculty members and research scholars. I request all the participants to attend all the sessions without fail. I am sure at the end of the program, you will get benefited and it will reach your expectations. Thank you, Anand. Now, I would like to request our CSE AI and ML HOD, Dr. S. Rao Chintalpudi, to address the gathering. Sir.
Am I audible?
Yes, sir, you are audible, sir.
So, good evening to all. Welcome to 6-day online FDP, ATAL FDP on advanced AI tools for IIoT framework. First of all, I congratulate Dr. K. Mohan Lakshmi Madam and Bandidas for getting a 1 lakh grant, FDP grant from ATAL and AICT. The topic is advanced AI tools for IIoT framework. You know that we are all faculty members and we need to learn day by day whatever technologies we got in nowadays, and we need to learn and we need to transfer that knowledge to our students. So AI is a buzzword, you know that it became a there means there is a possibility to do anything in any sector like healthcare sector and manufacturing sector and education sector, even education sector also. Okay, as our primary duty is teaching, so we should learn the things, the latest technologies around the world, and we should disseminate that information to the students for a better society. I hope all you people will utilize this particular FDP, all the sessions, and you get something and you transfer that knowledge to the students. Thank you. Thank you for giving this opportunity.
Thank you, sir, for sharing your valuable thoughts. We sincerely appreciate your support and encouragement. Now I would like to request our Dean Academics, Dr. TTV Dharmaji Rao sir, to address the gathering. Sir, please.
Madam, am I audible?
Yes, sir, you are audible, sir.
Yes. Our beloved director, Dr. A. Reddy sir, HOD of CSC AML, Dr. and Professor Malesh sir, and the coordinator, Dr. Mohan Lakshmi, and the co-coordinator, Bandidas, all the participants, researchers, PG students. Good evening to all of you. I welcome all the participants to a 6 days online ATAL FDP program scheduled from 24th to 29th November 25. So with the topic Advanced AI Tools for Industrial Internet of Things Framework, a framework for integrating OT and IT, operation technology and information technology. It's an excellent program. So on this occasion, okay, I congratulate the coordinator and co-coordinator for having granted the sanctioned the grant for organizing this 1 week online FDP program. So no doubt at all, the game changer nowadays is the artificial intelligence. Everybody knows. So in all areas, including the education also, the teaching also, we are using all the AI tools. It is inevitable. We can't avoid that. So recently, some case studies are, for example, in Rajasthan state, Tong district, the collector have implemented an AI tool called Padai with AI. By using that AI tool, the pass percentage in especially mathematics has been increased from 12% to 96.4%. So advantage of using the AI tool, Padai with AI. Similarly, another case is Adalat AI. Almost the 4,000 courts, Supreme Courts have adopted this tool, Adalat AI. The advantage of this AI tool is, so without any typist or steno, so in the real time, all the proceedings will be prepared. So that increases, the speed of the, judicial process without the support of any stenos and, all these things. And similarly, industry side, so right now in the TCS company, 5.93 lakhs employees are working. The TCS have instructed all the employees and to learn AI tools, and it started giving training, 1 lakh people per year. Participating with the AI tools and encouraging them to participate in hackathons, especially AI hackathons. So like industry, education, schools, Supreme Courts, all are using the AI tools because the AI is the game changer, no doubt at all. So in our education and research and for the students and for PG students, for all, we have to use the artificial intelligence tools. So finally, a truth and a touch of humor on a lighter note. The invention of the cooking boosted digestion but made our jaws weak. And another thing, the industrial revolution raised the productivity but made our muscles weak. Now the coming to the AI tools. Now artificial intelligence is boosting productivity but making our brains weak. So that is called from evolution to the de-evolution. So however, we have to use the AI tools because we are various comments we are receiving from the Elon Musk. So AI is ruling the entire world. And there is opportunities will be reduced, and for 25% of the code will be generated by the AI tools. So, and industry people are saying the people with AI knowledge are going to replace the people without AI. So we have to learn all the AI tools and we have to implement okay, in our education, schools, colleges, courts, industries, everywhere we have to use. So with that, okay, I want to conclude. I wish all the best, all the participants. So this 1 week program definitely, okay, would give or lighten the knowledge, especially how to use the tools, especially for this integrating the OT and IT. So with that, okay, you can continue your research, or you can deliver, or you can, okay, enlighten your students, okay, how this framework and technology AI tools will be working. So thanks for the opportunity, and once again wish you all the best. Over to you, madam.
Thank you very much, sir, for your insightful and inspiring address. Now, I would like to invite our director, sir, Dr. A. Rajareddy, to address the gathering. Sir, please.
Am I audible?
Yes, sir, you are audible, sir.
Hello?
Audible, sir.
Yeah. Okay. Good evening to everyone. The Department of CML HOD Dr. Subhash and the coordinator Dr. Mohan Lakshmi and Dean Academics Dr. Dharmaji Rao and other deans, HODs, faculty members, and dear participants. First of all, I would like to congratulate the CSCML department and especially Dr. Mohan Lakshmi for getting sanctioned this ATAL 1 week online FDP program and granted 1 lakh rupee for the same. And also, as you know that already our Dean Academics mentioned very clearly the impact of AI in the society. And because the change we cannot stop, but change, if you don't adapt, you will be outdated. So the reason every 4 years, if you see in the computer science engineering field, the changes will come, and every new cycle comes. The cycle is mostly for 3 to 4 years. Now the cycle is the artificial intelligence cycle is going on. So this is usually called as a disruption of technology. Definitely disruption of technology where you will lose the jobs, but at the same time, it gives us an opportunity to create jobs also. So let us not worry too much about the what is happening in globally. But if any tool we need to adapt, and the student community especially, for that purpose, the FDP programs have been organized, and for that purpose, ACT is giving approval and extending all the support. So thereby, I request all the participants, as our madam said, around 200 participants registered, but I could see only 80 plus people have joined this program as of today. I request everyone, every participants to be present all the sessions, and at the end of every session, we expect your feedback, and 100% participation and feedback only enable you to get a certificate. So this is what my sincere request to all the participants. So being a teacher, first we should be a role model, and hopefully we can train the students in right direction. So that is the motto of training the trainer, that is FDP faculty development programs. So with this, I wish all the department, the coordinators, and all the participants have a nice time for the next 6 days. So it is totally online. Around, I think every day maybe around 1.5 hours to 2 hours you need to spend. And if I look at the schedule, there are some eminent speakers from across the globe also sharing their expertise in this particular topic. So I wish all the best, good luck, and have a nice time for the next 6 days. Thank you all. Mohan Lakshmi? Hello?
Thank you. Yes, sir. Thank you, sir. Thank you, sir, for your motivating and insightful address. Your guidance always inspires us to strive for excellence. Thank you, sir. Now, I would like to request our Dean R&D, Dr. K. Srijan Raju, sir, to address the gathering. Sir?
Very good evening, ma'am. Is it audible?
Yes, sir. Audible, sir. Please.
First, I would like to congratulate all the participants and the coordinators, Dr. Mohan Lakshmi and Dr. Bandidas for this insightful FDP approved by AICT ATAL. So even the industry people are also joined in this particular thing to deliver the 6 days thing. So thanks for giving me the opportunity to address on this particular occasion. So especially when we are going to look at that advanced AI, when we are talking about RAG, and when we are talking about generative AI, when we are talking about Internet of Things, these are the old things. But right now, industrial Internet of Things is going to play a vital role. How we are going to optimize the solutions more effectively. So that was the reason I would like to tell you all the participants that the all the sessions have been scheduled very properly, and some of the international industry experts and the national industry experts who are having the expertise in this particular IIoT and artificial intelligence are going to address for the next 6 days, where you are going to get good knowledge and insights on this particular advanced AI tools, where you can utilize this to optimize the solutions. Like if you look at that, a lot of startups are also working in this particular area to optimize the solutions. Example, if we are going to look at that, Ashok Leyland, if we are going to look at that, a small error in that particular design is going to cost a huge. But by applying, before they are going to approve the model itself, by using AI technology, they are going to identify that. Even if we are going to look at that agricultural domain or healthcare domain or manufacturing domain, you take any particular domain where Internet of Things, by using that, we are going to gather the data and we are going to analyze that particular data by using the AI tools, and to predict the mistakes, or rectify the mistakes, or to improve the productivity, or to improve the efficiency. So this is going to be very helpful particular sessions which are going to be approved by AICT ATAL in online mode. And once again, I'm sincerely thanking all the participants and the coordinators and our college management for providing such opportunity for the young researchers and to the faculty fraternity and students to learn the things in this particular advanced techniques. And once again, I'm wishing you all the best. Thank you for giving me this opportunity.
Thank you, sir, for your valuable and inspiring address. We sincerely appreciate your continued support and guidance. Thank you, sir. Now, I would like to request ECHOD Professor Mallesh sir to address the gathering. Mallesh sir.
Thank you, ma'am. Am I audible?
Yes, sir, you are audible, sir.
So, good evening, everyone. So, respected dignitaries online, Director CMR TC Dr. A. Rajareddy sir, and Dean Academics Dr. DTV Dharmajirao sir, and Dean R&D Dr. K. Srijan Raju sir, and HOD CSC AML Dr. Subhash sir, HOD CSC Dr. N. Bhaskar sir, HOD Data Science Dr. K. Murali sir, and HOD IT Dr. K. Kavita Rani madam, HOD H&S and Keshav Reddy sir, and HOD MBA Harish Reddy sir, and today's program coordinators Dr. K. Mohan Lakshmi and Dr. Bandi Das. So congratulations and all the participants from various institutions across the globe, and would like to say heartful thanks to all the speakers who have accepted our request to deliver your expertise to all the participants. So this is excellent opportunity to learn, to showcase our knowledge towards the student community by learning the great experience from the people. So this is the wonderful platform to get the experience. And the title is mentioned, it is very clearly advanced AI tools for IIoT framework. as our directors and deans mentioned, this is going to be, plays vital role in the future. So it is better time to learn and to get experience, the same thing to be delivered to our student community. So once again, hearty congratulations to the coordinators. Both of you. So we are very happy with your coordination and your achievements. So hopefully these 6 days session will helpful to a lot in the student. All the participants who are there in this online meeting. In this particular group, definitely it will helpful for them. So thanks for giving support, ma'am. Back to you.
Thank you very much, sir, for your inspiring address. Now I would like to invite Dr. Bandidas sir to deliver the vote of thanks.
Good evening to everybody. I myself, Dr. Pandidas, the co-coordinator of this program. First of all, I would like to thank Sri Gopal Reddy sir, Chairman, CMR Technical Campus, Sri Vasantalata Madam, Secretary, CMR Technical Campus, Sri Abhinav Reddy sir, CEO, CMR Technical Campus, for providing wonderful opportunities to conduct this kind of programs. And I would like to thank our dynamic professor, Dr. A. Raj Reddy sir, our director, CMR Technical Campus. He is always available for us to conduct, to do any work. He gives permissions. Thank you very much, sir. And I would like to thank you, Dr. S. Rao Chandrapudi sir, HOD CSC AML, CMRTC. And I would like to thank Dr. DTV Dharmaji Rao sir, Dean Academics. And I would like to thank Dr. K. Sujan Raj sir, Dean R&D. And I would like to thank Bhaskar sir, CSC HOD. I would like to thank S. Malay sir, Professor S. Malay sir, HOD. And I would like to thank all the participants who were participating in this event. And I wish you all the best. Make use of this opportunity to upgrade your skills in this field. And I would like to conclude this with thanks. Okay, thank you very much.
Thank you, sir.
Thank you.
Dr. Mahesh sir is available, sir. Dr. Mahesh sir? Dr. Mahesh Kumar sir?
He is available, madam. He was
Yes,
joined.
ma'am.
Yes, sir.
Very good evening, Mahesh sir.
Sujan garu, good evening.
Very good
Good
evening.
to see you.
Sir, good evening, sir. Welcome to today's session.
Yeah, thank you, ma'am.
So now it is my privilege to introduce our distinguished resource person for today's session, Dr. Mahesh Kumar, CV. So Dr. Mahesh Kumar, CV is a trailblazer with over 2 decades of experience in shaping the future of software, analytics, and artificial intelligence across the leading organizations such as L&T Technology Services, IBM, Mindtree, and Dalmia Bharat Group. Beyond his technological expertise, he is a true torchbearer of knowledge, having conducted more than 400 workshops and inspired learners globally. He is also recognized an IMDA approved data science and ML trainer in Singapore and a 2-time SAP topic leader as well as an SAP mentor alumni. His commitment to nurturing the next generation of Indian innovators earned him recognition from the Government of India, which honored him as a mentor of change under NITI Ayog's ATAL Innovation Mission. We are privileged to have you with us, sir. Sir, I request Dr. Mahesh sir take over the session.
Yeah, thank you, ma'am. It's always a pleasure to be part of this kind of faculty development programs, and I have a good maybe 6 years association with CMR group of institutions. Especially thanks. Good to see Dr. Raj Reddy garu and Shrujan in the call, and even I can see Dr. Srinivas Padmanabhan as well. Good evening, sir.
Good evening. Good evening.
Okay. So we are on time. It's 6:28 p.m. IST. So perfect. So
Yes.
let me share my presentation. Okay. So can you guys see my screen? Can someone confirm?
Yeah, it's visible, and
Yes,
if you
visible,
can put
sir.
it into the slide mode, it is better.
Okay, yeah. Okay.
Yes.
So 90 minutes, next 90 minutes, I'll take you from basics to very advanced examples, which no theory, it's all applied AI basically. So, no, this is not the first slide. Yeah. So let's basically the title of the session would be Advanced Industrial AI Use Cases. So what I'll be covering in the next 90 minutes. So we'll start with a couple of examples how AI is disrupting various business with specific to the different industries. It would be a little context setting before getting to the right topic, main topic actually. Then we'll talk about what exactly the VUCA world and what are the different mindsets to adapt in to survive in the VUCA world. And then the actual topic, which is the four exponential industrial AI trends. So we'll talk in detail with the various use cases. And finally, we'll touch up with the in the reality how AI product development would be. And then finally, we'll end up with Q&A. That's the basic agenda of the session. If something still, if you guys are looking, maybe we will take at the end of Q&A. And it's good to see that in the next 6 days, the various amazing topics are lined up with the very eminent personalities from the industry and academia. So let's start. Yeah, this example is from our backyard Bengaluru. It's called, the startup name is called Tanbo Imaging. These are the people who are giving eyes to Israel Army, US Army, Indian Army. So if you look at for various components, they attached AI powered camera. They developed their own. So it's the Indian device, the most advanced tactical imaging system in the world. Imagine they have more than 350 plus components. So whether it's army, any kind of navy. So when the pilot is driving a MiG, where he will have a specialized spectacles, which is the camera attached with their components and which is AI powered. So these are a few examples on the screen what you are seeing. And this is crazy. One more example from our backyard Bengaluru. The startup name is called Ati Motors. See there, it's a 17 years kid who is the chief technology officer of Ati Motors. His name is Sadhna, sir. Ati Motors is they're trying to build autonomous electric e-cargo vehicles, and nowadays even they started doing a commercial autonomous projects as well. The third example, this is Flutura, Flutura Dation Sciences. They built a platform called Cerebra, which essentially targeted for oil and gas and the heavy equipment and the manufacturing industries. So irrespective, no need of knowing AI, but you can derive what are the insights you want to understand about your plant and day-to-day operations just using their platform. So they completely humanized AI in this industrial AI sector specifically. Around 2 years back, this guy started way back in 2014 from Bengaluru. 3x employees of Mindtree, and they ran almost close to a decade. They beated Shell, they beated Henkel, whatnot, the big giants they beated in these three industries. And recently it got acquired by even Accenture. So let's move to the other example. If you are familiar with Amazon Go, it's the same replica of that. They call it Vata Sale. And let me tell you, this is not from Bengaluru or Mumbai or Delhi. This shop is from Kochi. So once you get inside into the shop, you pick what are the products you want, and the bill would be automatically generated, and it would be deducted from your account. So there is no need to wait in the lane to just get your bill done, right? So that means technically there is no cashierless. It's basically a cashierless store, which is the first in Asia, the first autonomous cashierless store in the Asia. Just imagine. They just replicated and tweaked the Amazon Go, and they build the same model. Now let's look at how generative AI reshaping the IT cost pools. In oil and gas industry, very often we'll use inner corrosion detection. So we are asking generative AI, let's say if I'm the AI developer, I'm asking Gen AI to write a code to detect in Python to detect inner corrosion in refinery pipelines, which basically the input would be hyperspectral image as the input. So obviously the Gen AI will generate a code for you on the right hand side. What you see that's the code generated, and obviously we need to little augment the fabricated code. Then again, I'm asking generative AI to generate the top test scenarios to test this solution. On the right hand side, what you see, that's the scenarios which generative AI is generated. Then again, for my team, the salespersons, they need a sales kit. So I ask generative AI to what are the top 5 messages you'll be communicating to the customer and make it punchy with text and flavor and make a table on the right hand side. That is what the generated by AI. And third, again, we want to understand what are the sales blockers while envision the correction detection. So that's the right hand side what you see, the sales blockers for the sales team. And in the space, the corrosion detection solution powered by AI, we want to understand who are the competitors. So it's Rock Test, IBM, PCM, Codex, SensorUp. These are the 5 competitors. Give me a second. No. Okay. Can someone confirm what exactly are you able to see my screen?
Yes, sir.
Okay.
Tell-
Yeah, thank you. So these are the 5 top competitors for AI-based correlation detection. Now, if you look at before Gen AI, which is 2023, and now with the effect of Gen AI, so development time, which usually used to take 8 to 12 weeks, we got reduced to 1 week now, and even the same in the man weeks. And you usually, if you look at sales kit, usually it will take 4 to 6 weeks in the reality because it's all depend upon the right stakeholder. And unfortunately, we don't try to pull all the people in a one place. So that's technically in general, 4 to 6 days, 4 to 6 weeks it takes. But now, if you see here, it's less than a week. So this delta will start increasing with the time, which we are already affecting and we are impacting with the, of course, apart from Gen AI, there is even one more weapon called the fancy type agentic AI as well. So that means the delta is increasing as well with the time. Now, so at a high level, if you just try to understand how much does it cost to replace one human developer with an AI-powered agent or a coding agent. So typically in a Silicon Valley, which is $220K, in Indian, it's approximately $30K. So number of working days per year, if you remove all the weekends and holidays, it's approximately 260 days. Average lines of code checked per a day approximately should be 100 to 500, not more than that in a day, right? And average number of GPT tokens per line, which is approximately 10. And if you look at the cost per token, which is 0.02 cents, it's not even 100 rupees. And total cost of coding Copilot is 0.12 cents per day. So if you just quickly zoom in per day, earlier it was approximately $300 for Indian coders, whereas Silicon Valley coder is approximately $1,200. But now with the agents, Gen AI or agentic AI, it's 0.12 cents per day. So even Gen AI is reshaping the organization structures also. So earlier, it's all the human hierarchy, right? Where you'll have the AI head or a practice head. Under that, you'll have delivery managers. Under that, you'll have a product or a project managers. Under that, you'll have parallel, you'll have a solution architect, leads, then developers. But now we are going to, it's already started. The momentum already started, where we will be collaborating with augmented humans, that is co-pilots. So technically, we will be based on our project needs, we'll be using some kind of a co-pilots along with the humans. So that is how it is going to impact even organization structures, not only cost pools. So let's move to other example. Whenever if you get some time, just try to install this Effectiva in your mobile and start playing with that app. So once you install in your mobile and start giving pose in front of the camera like this, in a real time, it will rate your emotion. If you are happy, what is that percentage? Is it a 95, 93? If you are a spectacle or if you are sad, what is that percentage? In a real time, it will give score for your emotions. So you know that AI can detect more than 20 plus human emotions. And this example is crazy. You know that whenever you are getting enter into a theater or a comedy club, you need to pay a certain amount as an entry ticket. Where this guy says come up with a crazy model where your entry is absolutely free. So once you get inside, how many times you are going to laugh, you pay for that. So it's called pay per laugh. So each laugh will cost you 0.30 cents. And on the right hand side, if you see where I'm pointing, seat number 1 got around a 40, for which you need to pay $12. Similarly, seat number 3, which is 78, and he need to pay $23. And these guys are extreme. They introduce it pay per cry. Imagine for crying also you need to pay money. And this is one more example called Synthesia. You know that whenever you want to create a long, lengthy videos, basically always a video production is a bit difficult, right? Where someone has to shoot, someone has to edit, someone has to present in front of the camera, which is a very lengthy process and a manual lot of efforts, and various people has to involve. But these guys were Synthesia. Once you are ready with the script, just upload in the script, and the image what you're seeing and the screen is not Tamanna. She is an AI avatar. Like that, you can select out of 40, you can select any avatar. The way how human present, the same way these avatars will present your information, whatever the script provided by you. So that means video production is completely replacing with this kind of a platforms, AI powered platforms. So Synthesia, you can try. This is crazy. And this example is from again Silicon Valley. It's called the Lambda College. So they claim that education is a free here, absolutely, because before giving admission to any student, their AI model will predict if I give admission to X person, whether he's going to get a job or not. Based on that, these guys are going to give admission to students. And once the student is completed his graduation and once he get started working in a job, then he need to pay back 17% of his salary for the first 2 years. So it's completely outcome-based education. And if you look at, we spoke approximately 10 various examples. And what's common in this game-changing solutions? So I know that it's AI, IoT, data. Apart from that, if you know something, just type in the chat room. What's common in this game-changing solutions? Yeah, go on. I want you to type in the chat box. Come on, guys. I'm not seeing any messages in the chat room. What's common? Okay. So we spoke approximately 10 various examples. Now, apart from AI, apart from data, apart from IoT, what's common in these 10 examples? That's the question. Yeah, everything is generated by AI, of course. Man, okay, algorithms, okay, go on. Okay, at the core, there is a problem solving which is common, right? And there is a data product embedded inside. Agree? So which, of course, it's all are created by artificial intelligence. So AI is nothing but mimicking human intelligence into machines. So broadly, if you talk about AI, broadly there are three types of AI, artificial intelligence. We call it ANI, artificial narrow intelligence, which is specialized in one subject area. So if you're riding a bicycle, if you're reading a book, walking, right, one specific area in which AI is pretty strong here. And the second segment, which is AGI, artificial general intelligence, human level AI. We are right now we are at here. So still this space has to be matured. So let me give an example. I can drive my car in India. I can drive my car in Middle East, even in US. But the same, when a solution is built, autonomous vehicle solution is built for Hyderabad, you can't take that and you can maybe you can deploy, but immediately whatever the solution you built for Hyderabad, you can't take that and put in Middle East, right? So when that is possible, that humans are good at adapting to the circumstances and the environment. But whereas AI is still not. When that is possible, that's what we are talking about AGI. And the future is the third segment, which is ASI, artificial super intelligence. So in all perspectives, smarter than the humans. That's the meaning of ASI. The best example would be the Vasikaran robot, Chitty. So that would be the best example of ASI. Now, let me tell you, as major the guys in the room, you know that AI is not at all new, which is a 74 years of computer science application. So now quickly to rewind and sum up. So let's talk three transitions, what AI is doing right now. The first transition, so from AI as a feature to AI as the core. So there were the days where if you take 10 years back, AI was particularly using as a feature. So especially if you take YouTube, randomly you'll watch 4 or 5 videos and AI will understand your watching pattern and then it will suggest you the next video, right? That's a recommender system, which is a one tiny feature. Now, it's not the case. Now, major of the companies or startups, AI has become a core, which is the heart of their business. So if you take Uber, when you're trying to book a cab, now just remove AI from that app, there is nothing, right? So that's the meaning of AI as the core. In the second transition, from AI as a shrinking cost pools to AI expanding revenue pools. So those were the days when you want to implement artificial intelligence, which was a very costly affair, right? But now AI is generating revenues as well for the businesses. In the third segment, from AI by high priest to AI extremely democratized. So those were the days where AI was meant for only research scholars. But now, even if you look at the school kid, we saw one example of Asad Nasser. So with the age of 17 years, he is the chief technology officer. So like that, now its AI is completely democratized for almost even school kids as well. I want you to, I'm not sure looking at your internet, whether if you can see this video or not. So I want you to watch this video. there are a couple of examples of AI use cases.
Sir, your voice is not audible, sir. Please.
Teaching robots to assist, to watch out for danger, and help.
Hope now the voice is coming.
Yes, sir.
Perfect.
Save lives. I am a healer, providing a new generation of cures and new levels of patient care. Doctor, that I am allergic to penicillin. Is it still okay to take the medications? Definitely. These antibiotics don't contain penicillin, so it's perfectly safe for you to take them. I am a navigator, generating virtual scenarios to let us safely explore the real world and understand every decision. I even help write the script. Breathe life into the words en muchos idiomas y escribí la música. I am AI, brought to life by NVIDIA, deep learning, brilliant minds everywhere.
So now if you observe in that video, that music, even the music was generated by artificial intelligence. Now let's move to the second segment, the VUCA world and the mindsets. So if you look at Amazon, you know, the traditional business where they were selling books, but now Amazon has defeated borders, where Netflix defeated Blockbuster and Google defeated Yahoo. You know that Yahoo was very powerful search and chat messenger in 90s, but Google has defeated that, right? So the game is completely changing. If AI is not integral, you are no longer in the game. The game is completely changing. And what's the secret? It's all about ability. It's all about detecting patterns. So on the image, what you see, it's you are able to see and you are able to detect AHA, right? AHA. So for competitors, it's always ability to see patterns faster than competition is the key to survival. If you are not fast, obviously you'll be out of the market. So now quickly, let's try to understand. There are a lot of, on the down, on the x-axis, you have a time period ranging from 1900 to 2010 with a lot of gadgets like various items like electricity, air travel, cars, radio, credit cards, etc. On the y-axis, you have the percentage of adoption from 0 to 100%. So now if you take, if you took 70 to 80 years, 90 years, in fact, to reach even 100% to reach the adaptation, which took more than 100 or even 80 plus years. But very few. Well, let's quickly zoom the same examples what we saw in that 50 million users to reach electricity, which took 40 years, and I'm talking at a global level. Earlier example was the US Pacific, and credit card took 28 years, television 22. But whereas if you look at on the down, internet took only 7 years, cell phone took 12, iPads 4 years, YouTube 4 years, Facebook 3 years, and Twitter 2 years. Now let's look at 100 million users adoption. Google Translate took approximately less than 200, 500 days, and whereas Instagram took less than 1,000 days, whereas TikTok, which took even to reach 100 million users, which took less than 100 days. But whereas ChatGPT to reach 100 million users, it won't even took 30 days. So that's the kind of adaptation, how quickly, how fast we are using. So that means it is very evident that disruption is everywhere, which has become a new normal. And everywhere, irrespective whether it's healthcare, whether it's education industry, whether it's oil and gas, all the industries are vertically, horizontally got impacted with the disruptions, right? So with that, the world, what we live is called VUCA world. We use CA. We as a volatile, U as a uncertainty, C as a complex, A as a ambiguous, which means around 10, 15 years back, the world was so non-volatile. But now, at this juncture, if you look at in the next 6 months, which technology is going to come in and which technology is going to fade out, we can't even predict, right? So even till 2 years back, we don't know that there is something called Gen AI will come and which will hit us. Agentic AI will come and hit, right? So let's quickly unfold the future by 2028, looking at the VUCA world, how that world looks like. These are the little predictions by 2028. So I want you to just observe this video, please. So that was a video which by unfolding the future by 2028. Now, according to the Pentagon, which let's quickly look at the world by 2045. So that was the reason why I was talking about a VUCA world. Now, if you look at the various examples, how quickly the world, the surrounding world has been changed, and we are intimately surrounded by various algorithms, and we don't know from which direction the algorithm is going to come and it is going to hit. So finally, where humans are became the invincible hostages for a non-vincible algorithm. So winners are embracing with the new mindsets and tool sets where the game is completely changing, where the young startups and young kids are challenging, ironic big companies by solving various problems. So what discriminated radical companies from the rest? Do they have a huge knowledge? No, everyone will have the knowledge, right? Do they have a huge capital? Come on, we are talking about a startups. What kind of capital they will have? And do they have a huge networks? No, everyone will have a networks if it is a large organization or something. So what they have is mental habits. Mental habits are mindsets. It can be interchangeable. So let's talk about the few mindsets which people, winners, are embracing with the new mindsets, right? So the first one is mindset one. We call it moonshots. So think 10x times, not 10%. So let me give you an example. So Arvind Eye Hospital, when by doing little surveys, they understood that at a globe, there were around 30 million people. By doing a little surgical procedure where we can bring their eyes back. That was a challenge they kept. And parallelly, scaling 10 million ophthalmologists, onboarding 10 million ophthalmologists to do eye cataract operation for 30 million people won't make any sense, right? So that's where they went back and they stepped back. They built a solution which can be scalable and anybody can operate that. They took inspiration from Xerox machine and STD booths. The beauty of this too is anybody can go and in a less time they can learn and they can operate. So that's where if you look at the kind of AI-powered solution they built, so which is the hardware and AI-powered software as well. And the person who is treating, she's not an ophthalmologist. She got just trained in that machine and she's performing eye cataract operation. She's not doing diagnostics. That's the meaning of think 10x times, not 10%. Let's move to the mindset two. Mistakes as a tool always. So as early in the beginning, do as much as mistakes so that you learn from the mistakes. And we always shy when you want to share our mistakes, right? Rather than that, if you look at mistakes as a tool, so predominantly you need to share your mistake with the team so that they will learn from the lessons. There is a museum in New Zealand, which is a museum of failure innovation. So once you get inside, you will see all the stages. What was that problem they are trying to solve? Why it got failed? Where it went wrong? So you will see all the sequence of jobs. Let's move to the mindset three. So asking a question is not a good habit. It's always ask a right question rather. So if you look at this small girl or baby, 6 years girl, if she never asked a question, today we didn't have a great invention. So she asked the question, you know that in the 90s, always we have, now it's a digital, right? You can just use your camera, your mobile, click and digitally, if you don't want, you can delete and instantly you can see the image. But whereas in those days where you have the camera, inside you will have the reel, you have to complete all the reels, maybe 35 or 36 shots, and then you need to remove that reel and then send it for lab for washing, right? So that was the reason that a girl asked the question, Dad, why should we wait for the photo when it is got clicked? So that one right question, which led an invention of Polaroid camera, what we are talking. On the right hand side, the person who is the inventor of Polaroid. So Edwin Land, and she's she's the daughter of the Edwin, and that girl asked a question to Edwin. So see a beauty of this one powerful question which led an invention of Polaroid instant camera. The mindset 4, which is extreme empathy. So when you're solving a problem for the person to understand their pain, so you need to understand the essence of the problem. How is that possible? So you need to get into their world. You need to walk certain miles with them. Then only you will understand their pain. Until unless, if you never understand the person experiencing the pain, you're never going to build a right problem for them. So let me give you an example. If you're not able to understand the extreme empathy. So whenever if you're not feeling well, you will consult a doctor, right? So doctor will try to empathize into your world by asking various questions, right? So that is how, so there are various techniques and ways to do empathize and getting into their world. So it's always when you are solving their problem, you need to see the world through their lenses, that meaning the user eyes, not with our eyes. So the last one, the mindset 5, how quickly you can do how quickly you can do prototyping. So that's what we call rapid prototyping. You need to prototype in a 1 day, 1 hour, 7 days, 30 days. So because there are a lot of AI powered tools also nowadays where you can build extreme prototyping. So to quickly summarize, we spoke 5 different mindsets: moonshots, mistakes as a tool, ask a right question, extreme empathy, and prototype. So when you combine and start implementing this, your foundation, the roots are very strong, and the fruits will follow automatically. So we need to rewire the mindset. We need to fundamentally change the operating system in the head, which we are using outdated. Probably in the laptops, which we are using the latest operating systems, maybe Windows 11 or 12, but in the head, which still we are using our old. We need to rewire the mindset and update the operating system in the head. So we call apart from AI, when you combine with the various technologies, so that would be a force multiplier. So precisely, we call exponential technologies, AI, 3D printing, augmented reality, virtual reality, IoT, robotics, cybersecurity, now even DNA, quantum computing. These are all exponential technologies. So now let's move to the third segment of the session, which is industrial revolution, or more precisely the advanced AI use cases or exponential advanced AI trends. So you know that when we go back, the industrialization started way back with the 1.0 mechanization, which is, it's more about the steam engine. The second one is electrification, and the third is automation. The fourth is digitalization. Now we are talking 5.0, right? So the objective of 3.0 was more trying to automate, and the fourth was, it's more about leveraging the infrastructure and combining all together in a one place, right? It's more about the connectivity. But now if you look at the 5.0, so where we are saying human machine collaboration. So precisely, if you look at one side, we have all the data, and we have the cloud, we have 5G network. So we have connectivity in place. So finally, what we need to do is, earlier in previous versions, that decision intelligence was missing. Now we have data, we have connectivity, we have infrastructure. Now we are going to use the AI along with the human collaboration, which AI can interrupt your data to make decisions. So various ways and methods are there when you're talking about industrial AI. So there are a lot of facets of AI. When you talk about facets of AI, we got a lot of facets, right? Like consumer AI, industrial AI, security AI. So if you look at the advancement of industrial AI when you compare to consumer AI is pretty fast. It's almost 10 years, upfront when you compare over with industrial AI. So in which now it's a time that is the reason people started heavily leveraging AI for the industrial space, as we got predictions with the leveraging the traditional AI, and now we got more leveraging generative AI and computer vision as well, NLP other side. And apart from that, even now we got agentic AI as well. Now let's talk about the 4 exponential industrial AI trends. So the first one is we call vision intelligence, the exponential industrial AI trend. So in general, when you talk about various industries, not only manufacturing, so generative design, and how about when you are designing at a core level itself in the initial stage, how about doing real-time validation about that? So that's what we are talking about, a vision intelligence, where whatever the idea you have, you want to do that in terms of doing more generative design. So you can leverage computer vision to develop that, and in a real time, you can validate. Let's move to the second segment, second example. It's again from a manufacturing industry. So irrespective of the components which they are trying to produce or manufacturing, so there are chances where the human eye can miss some kind of things, right? But whereas if it is a vision intelligence, precisely the advanced version of your computer vision is nothing but vision intelligence, what we call. So how about micro defect detection? Now let's say while validation, there will be randomly people will do, but there is a chances of missing micro defect detections, right? So even you can adapt vision intelligence for the same. The third, this is from automotive industry. Now let's say the car, everything is assembled and it's got painted and everything is ready. But still, if you look in automotive industry, it's called deflectometry for the paint quality. Now, if you look at unless, even if you close and zoom it by with the closure, even if you observe, you can't understand that whether there is a defect with the painting. There will be some kind of a shadows or some kind of a reflection would be missing. So even that can be automated and using vision intelligence. Now, we know that very often the driver behaviors, right? Now, how about scoring the driver behavior? So while driving, whether how much time is speaking in a mobile, how much time he is a little drowsiness. So that way, so it's just about installing a camera, and once you got the data, you can apply your vision intelligence, right? So that's the driver scoring models to understand the driving, the driver behavior, the pattern of driving, and you can score as well. So if you look at this digital journey of a vision intelligence, it's so earlier it started with a machine vision, and then AI enhanced inspection, where very often we started using computer vision there, and then human and robot collaboration. So we call it cobots. Probably when we talk after some time, we are going to talk about cobots as well. And then digital twin and simulation. And then finally, the 6th is fully autonomous operations. So that's the basically digital journey of vision intelligence. So precisely, we are at here. So the intersecting point. So we are, so a lot of big corporations started, especially in a textile, especially in a manufacturing industry, For the AI enhanced inspection, it's automated by AI. And for few industries, they just started leveraging cobots in place. Now let's move to the second segment, which is exponential industrial AI trend 2, which is robotic operations. So now if you look at along with the robots, it's called cobot actually, collaborative. In industrial space, people started leveraging where it can augment with the human. And now if you look at the lady here, she is trying to build something and the cobot is helping. So that is what I'm talking about. It's cobot. Now let's quickly understand how robots are using in a manufacturing industry. This example is from Boston Dynamics. So this Boston Dynamics, it's already started, and these robots are already in production. It's live. So a lot of companies started using this, and this got introduced way back in 2017 or 18. But now it's more than even 100 pounds kind of a weight also they will lift. And let's look at one of the other example, gallbladder surgery in a healthcare. Without human intervention, the robots are performing surgeries. There is no human, there is no surgeon here. It's everything end to end done by robots. End to end. Now let's look at this is an end to end autonomous assembling of a car. So there is no humans, probably just humans will be observing. That's it. It's just for the backup purpose. But if you look at starting from the each component assembling of end to end, it's done by robots. Even if you look at Kia, so majorly the Kia is 90%. Let me put it in that way, not 100%, but 90% it's assembled by robots. So now if you look at the digital journey of robotic operations, so it started with, as usual, the manual labor. Technically, in other words, it's with humans, and started with the level 2, which is the few manual activities got automated, and then the level 3, which is basic robotics with the vision, and then human robot and collaboration, then digital twin and simulation. Finally, the fully autonomous operation. So for any digital journey, if you look at the last level would be always the fully autonomous operations. So let's pause here, and I'm happy to answer if you have any questions. You can unmute yourself, or if you don't have that option, you can just type your question here.
Dear participants, unmute yourself and any queries kindly ask, and otherwise you can share it in chat box.
Any questions? What's mean by digital twin? Yeah, so digital twin will be studying the next. That will be the next topic. We'll start. Okay, let's move to the next topic, which is digital twin. And let me, yeah. Hope you guys are able to see my screen.
Yes, sir.
Okay, perfect. Yeah, someone was asking what is digital twin? Yes. So a digital twin is a virtual replica of a physical object or a system or a process. On the left-hand side, if you see, this is the physical, the real world object. On the right-hand side, which is the replica of the physical object, whether it might be object or a system or a process, anything, if you can make it, in other words, duplicating digitally. So that's what we call it, digital twin. So precisely, a digital twin is nothing but a living 3D model that behaves just like the real thing. So engineers or operators can test, monitor, and predict what will happen before it happens in the real world. That's the beauty of digital twin. And precisely if you look at, when you're trying to understand exactly the digital twin, there will be three components. One is a physical asset or an entity. This one in the real world might be a machine, building, a factory, or even a city. So that's the physical asset or the physical entity. The second component, which is the virtual model or digital model, the software simulation of the real object, real world object or asset. Then the third is data link, so which basically a data connection. Using that data, we do analytics, right? Sensors and IoT feed live data into the model. Now, if you look at the role of AI, with the digital twin, you are going to simulate the real world object. And with the AI, as once you got the data, you are going to do prediction. So predict machine failures before breakdown, optimize performance and energy usage. Even you can simulate what if scenarios, reduce the maintenance cost and downtime. Even if you want to train your resources in the plant where your plants are multiple plants are located, and you don't want to travel in person for each and every plant, Even you can train your staff in a virtual environment. So apart from that, if you look at quickly, let me give you some of the examples, industry specific. So when you talk about a manufacturing, which is the virtual copy of a production line for a throughout your improvement. If it is an aerospace, digital model of jet engines for predictive maintenance. If it is a healthcare, digital twin of a human heart to test treatments. If it is a smart cities, simulate traffic, energy, water distribution. Now, let me give you one quick examples in an industrial sector. This is on the screen what you are seeing. A person is not monitoring. So there is a one component which is virtually you are able to see the blue screen, right? So this is the one of the component of aircraft, and physically he is located in somewhere. The plant is somewhere located, and virtually he is connect and he is fixing. Just observe that video. So if you look at, he is not diagnostics any asset or something. He is fixing that component. So let's take one more other example, which is predictive maintenance for the assets. So in general, you will have all your sensor data. With the sensors, you'll get all that data in terms of vibration, temperature. So depend upon the kind of sensors what you're using. And there is a predictive maintenance for the each assets, right? And proactively, wherever you want to get some alert or something, when you implement digital twin, that is where you are going to fix. As I said, the digital twins can predict machine failures before breakdown. So this would be the one very often popular use case where predominantly in corporate world people use. Next, let's move to the second. So even before doing any prototyping, let's say whether it's physical or a digital prototyping, now instead of building your physical object in the real world, where you can have a twin of that and you can simulate. So if you remember in the session when I started the exponential industrial AI trends, we spoke about generative design, right? So this is what I'm talking about. So even digital twin you can use here also. So if you just try to understand the digital journey of a digital twin, so it started with a manual process and a basic monitoring, and then the connected assets, so IoT, and then predictive analytics. So real-time digital twin, so which we are between 4 and 5. We are here now. So few organizations started using digital twins, especially in a aerospace. So Airbus, they're using predominantly digital twins. The final stage is which is fully autonomous. So for any digital journey, if you look at, it would be the fully autonomous operations. Now let's move to the fourth exponential industrial AI trend, which is IoT sensor fabric. So let's start with what exactly IoT sensor fabric. It refers to a network layer of interconnected sensors that continuously collect and share data across machines, process, and environments. Like something like similar to digital nervous system for an industry. So why we call it fabric? Because the sensors are spread everywhere, whether it would be machines, in equipment or environment, right? They're intron and communicate with each other. So that data flow seamlessly across the system. Probably in other words, think of it like a fabric of a tiny smart eyes and ears covering an entire factory or a city, all sending data in a real time. Let's take one. What does sensors, the IoT sensors fabric can do? So which can, primarily it can monitor machines in terms of the health. So how is the temperature, vibrations, pressures, right? So tracks energy, or in other words, even water usage, defects safety or environmental risk, tracks productivity, movement, and inventory. So precisely, if you look at the core components on this, I think, no, not this. Yeah. So the core components would be sensors and edge devices, which will capture the data. Then the connectivity comes, whether it would be Wi-Fi or 5G or LoRaWAN or WLE. So there are a lot of connectivity options, right? And then the data platform, whether it would be some kind of a cloud platform or a edge storage. Then the security layer, then integration with the AI and digital twin. So precisely, it's 5 core components. And sorry, I forgot that image somehow. I thought of replacing that. So in general, let's take one of the industrial plant. So layer-wise, if you look at sensors, motor vibrations, values collected every second, and gateways, aggregated and filter data, edge computing, in a real time, anomaly detection can be used, and cloud AI, which predicts your failures. In a simple analogy, just like nerves in a human body carry signals to the brain to prevent harm, right? IoT sensor fabric carries real-time signals to analytics systems to avoid failures. So now if you look at one of the example here, what I'm referring, which is a fully body medical grade monitoring suit. The person wearing is a suit where there are a lot of sensors attached to that, and where in a real time you can monitor their health. So this is no more a theory, no more a concept. On the right hand side, if you see, Exoskin is one startup which they developed this, and Astroskin. Even when we are sending astronauts into the space, where in a real time you can monitor and sense their health. It's more about a monitoring. And the third is ChronoLife. These are the 3. Just to give an example, these 3 are already started using and implemented these concepts. Now let's move to the other example. Even the same, how we are talking about the suits which can monitor your health. Now the same suits are developed for understanding the athlete performance and even injury prevention as well. So how about having a kind of a suit which will avoid injury for the players? So if any player met with any injury, he has to lose a lot of time, right? Depend upon the injury, ranging from 6 months to 1 year, 2 years, sometimes even a lifetime. So just to avoid that, that's where even the suits are built for athlete performance and for injury prevention as well. On the right hand side, what you see, these are the startups who build these suits for athlete to understand athlete performance and injury prevention. So Whoop, Wearable, Stretch Sense, and Kitman Labs. These are the 3 startups which they are already built the suits. Now let's quickly understand the digital journey of the IoT sensor fabric. So earlier, we started with manual monitoring and then point sensors and PLCs. Then the third, where we started with connecting assets. So more precisely leveraging IoT. Then fourth is a sensor fusion, and this is where we started leveraging edge here. And then 5, digital twin and AI analytics. Then the sixth is self-optimizing fabric. So before moving to the next topic, so any questions? I'll pass here. Yeah, I have some questions here. Let me read out for you. It is necessary to have a knowledge of programming coding to develop new AI tool for any industry. As a mechanical background, should I focus on a AI tool development or uses? No, not required. So earlier, if you are referring to the traditional AI, yes, you need to learn Python, and you need to learn even a machine learning techniques like regression, classification, clustering, and then deep learning, in which you need to be familiar with LSTM, long short-term memory, convolutional neural networks, recurrent neural networks. But now, as you are coming up with your mechanical background, which that is your domain, there are some agents now. So like we have Devika, we have Cursor, we have Replit. There are a lot of AI tools, coding tools. Using that, you can write down whatever the code you want. So no need to learn now, as you're coming from mechanical background. So that's the reason I'm suggesting. So to answer, no. Yeah, once I'm done with the session, I'll be sharing the presentation, guys. I can see a lot of people are asking about presentation. Yes. Okay, any questions? Okay, perfect. Now let's move to the last topic of the day, which is AI product development lifecycle. So broadly, it would be 7 stages. So it is very essence that you need to spend much time to define your problem. So when you are building a product, it is very essence to understand the essence of your problem, and you need to crystallize the problem for which you are trying to solve. So how is that possible? Just with the user empathy. You need to spend as much as time with your users to understand their pain, and you need to, until unless if you don't experience that pain, you're never going to build the right product for them. And as we have a lot of tools are available, so that's the reason now, before building the product itself, you need to understand the competitive. So who are the competitors and how much value you are going to unlock when you solve this problem, to precisely to understand how, when you are going to reach your return on investment, all that. So the third step is very essential. And once you identify the problem, instead of directly jumping into the engineering stuff using AI, so how about having a quick prototyping? So there are a lot of tools which you can do prototyping. And after that, start infusing AI. So your AI engineering will start here. So that means 1, 2, 3, 4. So still these 4 stages, you don't require AI. This is all your understanding your business process, right? So here, this is where you are going to build your actual solution, and you need to, where the, so nowadays very predominantly we are using agentic AI, right? And then you need to simulate, you need to do a lot of testing for that. Earlier, there was a problem where you don't get the data, right? In testing in the real world. But now if you see, even you can fabricate, you can generate the synthetic data as well. And then finally, smart iterations based on the feedback what you get in a testing. And it's always, so keep human in the loop. So as I said in the beginning, so it's more about defining your problem. So even you can use some of the tools while understanding your pain points, or so there are various ways to empathize, right? So one would be interviewing, one would be asking questions, one would be survey, and one would be continuously doing shooting, capturing their videos. So on the right hand side, what you see while defining the problems, you can use these tools, which is AI powered. So Notion AI, Miro agent, and this is a very advanced agentic AI tool. Then the second, user empathy. So as I told you, when you want to do that empathy, you need to spend a lot of time. You need to understand the user journey, right? And what are the various ways they are going to use. So parallelly, what we can do when you are interacting with your users, the core users, even if you have someone from with the background of agentic AI, you can build an agent, empathy agent, even a fairness agent. So now, if you look at this month, first week, Indian government has introduced AI Act. So if you look at the technology is always ahead of our laws. We don't have a control here, right? So that was the reason for every country, they introduced responsible AI. So in which AI governance for India, which got introduced this month, first week. So last year, European Union got, for the first time in the world, they introduced AI Act. So it is something like whenever you are using artificial intelligence for your business, now you need to follow strictly the guidelines from the country-specific AI acts. Once the European Union has introduced it, after that, various countries got introduced it, and India took a lot of time. And so maybe I think tomorrow we have a session by Dr. Srinivas Padmanabhani, right? Even Srinivas Padmanabhani is one of the stakeholder while drafting this AI governance policy for India. Maybe when if you get some time tomorrow, ask Srini. He will share some of the things on a responsible AI Act for India. So now coming back, so it is very evident and essence that you need to spend a lot of time with your users to understand their pain. And these are the various tools leveraging, you can do more effective empathy with your users. And third is competitive foresight. So when you know that you are trying to solve a problem and using these tools where you can now let's say while understanding the problem before building the solution itself, you want to understand whether are there any patents in and around this area, or you want to do some kind of IP specific. That's what I'm talking about. Mode forecasting also possible, and feature gap analysis. On the right hand side, what you see, AlphaSense, PatSnap AI, and Google, the patent agent. So these are the three tools which you can use. And from agentic perspective, you can build these agents, foresight agent and ethics agent. So if you look at previously also, we are talking about fairness, we are talking about ethics. That's more from a responsible AI perspective. The four AI-driven prototyping. So as I told you, so how rapidly, how quickly you can do a prototypes. So there are a lot of prototypes tools are there, and on the right hand side you can see UIZAD and user testing AI, Galileo AI. So these are AI powered, but apart from this, there are a lot of tools are available in the market. Then once you build your solution, you need to test rigorously and you need to simulate a lot of new data as well, right? Of course, with the tools, Gremlin and the DeepMind, Muzero, and Isaacsim from NVIDIA. These are the tools while testing your products. You can leverage them for testing and simulation. So finally, once you got some feedback in the testing phase, so again, you need to iterate your product. So for that also, you can use these tools like Arise AI, True ERA, or even you can use Gremlin. So here explain. These are the various tools you can use it. So AI. So now looking at the opportunities what you have with the AI is a massive once in a lifetime opportunity. This kind of wave we never had in a software industry, especially with the generative AI, agentic AI, and responsible AI. So the next 3 to 5 years would be very crazy time. So more precisely, if you look at to summarize, AI explosion has already begun. Generative AI is more from creator perspective. Agentic AI is more from actor perspective. And responsible AI is more from guardian perspective. So we call, when you combine these three, we call it agent Trinity AI. So it's very crazy stuff. So you need to combine these three whenever you are building some product. So still you can connect me in the LinkedIn. So my ID is this one, Dr. Mahesh Kumar CV. And you can see a lot of blogs on my name in a industrial space. There were 300 plus blogs are on my name, especially in a agentic AI, a responsible AI, and a generative AI space as well. So that's it. Humans are hooked, machines are learning. So still, if you have any questions, I'm happy to answer. We have some more time now. So India is going to become a global AI race and find your path. So thanks for the opportunity, and I'm happy to answer if you have any questions, please.
Dear participants, please, if you have any queries, kindly post the chat box, otherwise you can communicate. So if you don't have any queries, we'll move to the next session. So a very good evening to everyone present here. On behalf of our institution and the entire FDP organization committee, I extend my heartfelt gratitude to our esteemed resource person, Dr. Mahesh Kumar sir, for delivering such an insightful and enlightening session today. Your detailed explanation on advanced industrial AI use cases, AI airline pilots, and vision intelligence truly expanded our understanding of how AI is transforming real world operations. The way you walked us through the digital journey of vision intelligence in the industrial AI landscape, as well as the robotics operations in the industrial AI space, was highly informative. So, once again, thank you, sir, for your valuable contribution. We look forward to more such enriching interactions in the future. Thank you, sir.
Thanks, Lakshmi Garu. So everyone, thanks for your patience and listening to this session. And I enjoyed particularly this session. And so looking
Yes,
forward
sir.
to the next sessions, and all the best for your upcoming sessions. There are amazing topics and various eminent speakers are outlined. I just look at the session. I think next session is agentic AI. So that was the reason I was not talking much about agentic AI. So I thought of looking at all your sequence of topics for the next 6 days. So I thought it would be some kind of appetizer, and it has to be ignite for your all the upcoming sessions. So thanks everyone, and have a nice day. Thank you.
Yeah, sir. Thank you, sir. Andit, sir? Dear participants, kindly wait for 2 minutes.
Still, I am here, guys. If you have any questions, you can type here. So meanwhile, the other
Yes.
speaker comes, I'll try to answer your questions. Oh, I can see a lot of good messages. Thank you, Jay Lakshmi. Thank you, Radhika. Thank you, Ravinder. Ravinder Naik, sorry. Thank you, Durga. Glad that you guys thank you, Sumit.
Yes, sir. Dear participants, kindly wait for 2 minutes. A speaker is going to join. Take a break for 2 minutes or 3 minutes. Anirudh sir, am I audible?
Yes, ma'am. Yeah, you're
Yes,
audible.
yes, sir. Sir, good evening, sir. Welcome to today's session.
Thank you, ma'am.
With great pleasure, I introduce our distinguished resource person for this faculty development program, Mr. Anirudh Kasturi. He is a seasoned AI researcher and programmer with 10 plus years of experience in large scale systems, machine learning, and language modeling. He is experienced in applying advanced machine learning algorithms to a variety of domains, including finance. Passionate about building AI systems that leverage large language models and solving real world problems, particularly in financial data sets, skilled in mentoring and leading teams in the development of high quality AI systems. So, we are truly honored to have you, sir, and accomplished research with us today. Thank you, sir. Welcome, sir. So, kindly have a session.
Thank you, Ram. Thank you for the warm introduction. Shall we just wait for like a couple of more minutes and then?
Yes, sir. Yes, sir.
Okay, sure.
Yes, sir. Sure.
Yeah, maybe before we
Yes, sir. Yes, sir.
start.
Participants, they are taking some
Yeah,
time.
sure. So before we get started, like I think almost about 100 are here.
Yes, sir. Yes, sir.
I think if some of you or a couple of you can just put in the chat as to what your expectations are from this workshop, I can fine tune my content based on the requirements, right? Like for example, all of you are aware that this session is more about agentic building agents and then how to go about running some agents. Is there any terminology that you are not familiar with but you want to know, like for example LLMs or neural networks, deep neural networks, right? GPTs. So if you have any queries on that, just put it on the chat. So I will fine tune my presentation based on your knowledge and your exposure towards AI and ML. So probably take the next couple of minutes to understand your because it's a wide audience, right? That's the reason. So I just want to understand, just to get a grasp of how the audience are, and then probably take it forward. Okay, so let's just begin. Again, before we start, a couple of usual instructions. I want every one of you to please mute because again it's a large crowd, so I just it'll be disturbance for others. So please mute yourself. Any questions? Just raise your hands, and then I'll unmute and then. Okay.
నేను వెజ్ అందుకే నేను వెజ్ చెప్పు రాజా అయితే దానికి ఇచ్చింది వెజ్ సూప్ కాదు అదే
Mr. Narendra, can you please mute yourself?
రాజా సూప్ తాగుతావా
Okay. Okay, great. Okay, just give me 1 second. Let me. Okay, let's start with the first primary concepts of AI, right? So all of you are familiar with. Okay, I think there's. Just give me 1 second. I think you're able to write it here.
Sir, your voice is not audible.
Oh, I'm so sorry. I think I was on mute. Okay, so let's just do a quick recap. So over the last couple of years, so we've been hearing a lot of transitions, companies building on top of AI. Any company that you pick is actually doing AI, right? You see a lot of colleges doing courses on AI. But if you go back like 5 years or 10 years before, this concept of AI was not there. Like it was actually probably an elective in one of the computer science courses. But then all of a sudden you see AI being used everywhere, right? In every college. So what happened over the last couple of years, right? How did people transition between something called as machine learning? From machine learning, how did people transition to something called as deep learning? And from deep learning, how did people transition to something called as LLMs, right? So what was the transition, or why did the transition happen in the first place, right? So what is the fundamental concept of AI, right? When you talk about intelligence, what is this concept of intelligence? How do you define intelligence, right? So intelligence can be defined based on something called as decision making, right? So is decision making the most important aspect of it? How do you take a decision, right? So in order to take a decision, what is more important is information, right? So how do you say a student is or a person is intelligent, right? So you'll say a person is intelligent when he takes a decision based on some information. Now, if a student is able to, or if a person is able to take a decision, do we always call him to be intelligent? The answer is obviously no, right? So what is more important is taking the right decision, right? So if a person is able to take a right decision based on the information that he has, then you will call that person to be intelligent or smart, correct? Now, let's just take an example of, let's say someone is walking on the road and he's supposed to cross the road. Okay, now without looking at the traffic, if he just walks on the road, obviously we'll say, okay, why is this guy, does he not have some common sense, not looking at the traffic and then crossing the road, right? So you'll not call him smart or intelligent, you'll probably call him as dumb, right? But if that same person is actually looking left and right, looking at the vehicles, looking at the traffic, and then taking an informed decision to cross the road, then you'll probably call him as a smart guy, right? Now correlate this to something when a machine is doing, right? So you provide all the information to the machine and the machine is able to take a decision and the decision turns out to be right, then you call that machine to be intelligent. And now because it's a machine, you call the machine to be AI or artificially intelligent, right? That's primarily the definition of AI. So one such example that you can always think of is like your smart cars, autonomous vehicles, and all those things, where you take a lot of information from the surroundings, right? And based on that information, the computer that is sitting inside the car is able to take a decision. So if you look at what kind of information the computer actually has, so you will probably see information that is coming in from the sensors that are attached to the car, the cameras. When I say sensors, it could be obstacle avoidance sensors, it could be the cameras, right? It could also be the data that is being provided from the cloud, that could be the traffic information, right? Route optimization, which route it has to take, the destination, what is the route, best route to take, all that information coming in from the cloud. And based on all this information, the car is able to take a decision on which route to go, where to go, when to stop, right? At what speed it has to go. So all these decisions are being taken by the car in order to reach the destination. So that's why we call these devices as artificially intelligent, right? Now, what led to a genuine interest in all of us to move towards AI, right? What is the main factor that has pushed all of us to move towards AI? So the answer is very simple. First, it's obviously the internet, right? So internet, the advantage of internet made sure that all the data from the devices is actually reaching in one place, right? All the data from all the devices is reaching in one place. The second reason why there's a lot of interest is because of the hardware, right? So you have a lot of compute available, so that based on the existing data and the hardware, you're able to learn something from the data, right? So what is the benefit of learning? So when you learn, you're able to take a informed and a right decision, right? Based on historical data, you're able to do some kind of prediction. Now, all this ML, for those who are very new to machine learning and data science, the machine learning algorithms can be classified broadly into two categories. One is something called as a classification problem, or the second one is called a regression problem, right? So what is a classification problem? A classification problem is basically giving an output in terms of a real number or an integer number. Like for example, fixed set of classes. For example, you want to say whether it's a cat or a dog. You want to say whether it's an orange and an apple, right? So the output is fixed. you just have to choose between multiple values, right? So the other set of problems is basically a regression problem. Regression problem is where the output is generally a real number. Like, for example, you want to predict what is the stock of, let's say, Reliance 1 year from now or 1 month from now. You want to predict the temperature for tomorrow. You want to predict uh, the land cost for the next 6 months, right? You want to do some kind of forecasting. So the output of the algorithm is generally a real number. So if you just do a quick recap, any ML algorithm will either solve a classification problem or it will solve a regression problem, right? So which means the ML algorithm will either tell you whether it's like a positive class or a negative class. Like, for example, if you go to a doctor, the resultant output could be, okay, whether you have diabetic or you don't have diabetic, or it could be like a real value, like you want to predict what is the insulin for a particular patient over the next 6 months, right? So these are the two class of problems that an ML algorithm will solve. So what is the concept of deep learning? So you know that ML is actually classification regression problem, but why did people move from machine learning to deep learning, right? So traditionally, the machine learning algorithms were applied on small data sets. So probably about 1,000 entries or 5,000 entries or 10,000 entries. And as and when the data started growing, these algorithms were either not very effective, or they used to take a lot of time to give you some kind of output. So research scientists came up with better algorithms that could perform faster, that could learn faster, that could train faster. So the concept of deep learning has evolved, right? So not just that. So these existing machine learning algorithms were actually built on top of data sets that were, let's say, tabular in format, right? Like rows and columns. But with over time, you see a lot of data sets like image, video, unstructured data like images, videos, audio files, all these things coming up. And these traditional machine learning algorithms were not able to solve for such kind of problems. So people invented algorithms that could actually train on top of these unstructured data like images, audio and video, right? Like, for example, when you give an image to a particular algorithm, you want to predict whether there is a name in that, whether there's a letter in that, whether there is a cat in that, there's a dog in that, right? So image processing algorithms and all those things fall into this category of deep learning. Okay, so now any quick queries so far? Any quick questions so far? Okay. So now the transition from ML to deep learning happened primarily because the data became complex, right? So the moment the data became complex, people started looking for better algorithms. So one algorithm led to another algorithm led to another algorithm, and so on. And now from deep learning, people have started using something called as LLMs, right? So what does LLM stands for, right? What is the primary, what is the definition of LLMs? So LLM basically stands for large language models. So this is something that all of us would have heard about in news articles and newspapers and classes, wherever, like probably for the last 2-3 years, when ChatGPT actually came into picture, people started to hear about this term called LLM. So what does this LLM stand for, right? So LLM stands for large language models. Okay, now when you say large language models, what does this large indicate? What do you mean by the term large in this LLMs? Can anyone give me a guess? When you say large language models, what does large stand for? What does large stand for in large language models? Okay, so someone mentioned big data and someone mentioned parameters, right? Both of them are actually correct. So large stands for large amount of data and also large number of parameters. Okay, now someone said parameters. What do you mean by parameters? What do you mean by parameters? Okay. Okay, so large stands for large data. That is something everyone is familiar with. Again, for someone who's actually very new to machine learning algorithm, machine learning models or ML in general, model parameters will probably take a step back and then take you into some fundamentals of ML. So when you okay, so let's imagine you have two parameters, right? Now, let's say you want to decide whether a patient is diabetic or not in based on, let's say, two values. Okay, so what are the particular features that will indicate whether a person is diabetic or not? Let's say insulin levels is one, and then let's say you have the age factor, right? So let's say these are the two parameters that will indicate whether a person is diabetic or not. So yes, let's say insulin is 120, 45, right? So 200, 50, yes. And let's say you have some other parameters like this. Okay. Now I hope this data set is very clear, right? So you just have two parameters here, two features that will tell you whether a person is diabetic or not. And then you have a label that says whether a particular person is diabetic or not. So you have some values here, right? So now all the diabetic patients, we're calling them to be crosses, and all the non-diabetic is zeros, right? Crosses and zeros. Now let's say on the x-axis you have age, on the y-axis you have insulin. Okay, so now what is the goal of an ML algorithm? The goal of the ML algorithm is to find some line or a polynomial that can divide these two classes. So you have the negative classes here, and then you have the positive classes here, or you have the positive classes here, you have the negative classes here, right? So now one such algorithm, which we will not get into detail, is, let's say you want to find a straight line. You want to find a straight line that will divide these two classes such that whenever a new point comes, you will be able to figure out which class that particular person belongs to. So this process of finding the right line is called training. So this is something that you will always hear, that okay, what is, when you train a model, okay, what is the meaning of training a model? So obviously by first instance you will not know what is the right line, so you'll probably find that okay, you start off with this line, and then you'll figure out that this is not the right line, and over a period of time you'll figure out that okay, this is the line that is dividing the positive classes and the negative classes, right? Now in this case, this line can be represented by a straight line, and we all know that the equation of a straight line is y is equal to mx plus c. Let's say the values of m and c are 2 and 3, right? So the values of m and c are 2 and 3. So in this particular example, where you have two features and you found out a line, that is actually dividing both the classes into two parts, right? So this is the line that is actually dividing the classes into two parts, right? So in this case, the values of m and c are called model parameters, right? The values of m and c are called model parameters. Now, when a new patient comes, let's say the patient values are 120 and age is 45, right? Now you want to predict whether this particular person has diabetes or not, right? So let's say this guy falls somewhere here, right? Now by looking at this, you can tell that okay, this person is actually non-diabetic, right? Because it is on this side of the line. So any patient who falls on this side is non-diabetic. Any patient who falls on this side of the line, the right side of the line, is diabetic. So what we have done is we've tried to find out a line that is able to divide the positive classes and the negative classes, right? And this process of finding out the right line is called training. And once the training is done, your model is ready, right? And the model parameters are nothing but your M and C, the slope and the y-intercept. Now, when a new point comes in, your goal is to do a prediction saying, okay, whether this particular person is diabetic or non-diabetic. So the values of, when you substitute these values here and then you figure out that this is on the left side of the line, you will say, okay, this person is non-diabetic. So this is the prediction that we've done. And the model that we've used is y is equal to 2x plus 3, where the model parameters are 2 and 3, right? Now with complex data, like for example, now in this case, we were able to do a linear classification. Let's say you have data points are not linearly classifiable. So you have, let's say, points like this, right? So now you can't draw a straight line. You would need a complicated model. So from linear, you might probably go to a quadratic, which is like a circle, right? And in that case, the model parameters will change. And similarly, as your data becomes complex, you will need complex models, right? So now you move from a linear model and now you're moving towards a polynomial model, right? So now you want to find out a line. Obviously, you cannot draw a straight line that will divide the positive classes and negative classes. So now you need probably a more complicated polynomial. So from these, we can understand that as and when the number of features keep increasing, number of data points keep increasing, it's not simple to just draw a single straight line that will divide both these positive and negative classes, right? So you need more and more complex models that will help you in classification of the data points. Now, from these, we will see something like, probably if you've heard of the term called deep neural networks. So you will probably have complex networks like this, which are interconnected nodes, right? Where you have the inputs here, and then you have an output here. So all these models have been built so that complex data can actually be classified, or you can actually use regression algorithms on top of these complex models to predict some values in the future, right? So this is the primary reason. So now in this case, the point we're trying to understand is the model parameters, right? So these model parameters. Now, as the model gets complicated, for example, if you look at the polynomial here, the polynomial can, let's say, be represented as w1 x1 plus, just give me 1 second. Okay, so with these model parameters, as these model parameters get complex, right? So we try to find out those model parameters in order to do the classification or the regression problem. So now, when your data becomes complex, complex, the number of models parameters that are required to do the classification also will increase. So now when you come back to these LLMs, now you can understand that the models that have been trained on are actually trained on large data sets, large books, websites, lot of information, audio, video, and all these things. And then you have huge models that have been trained that can do your task. Hence, the term LLMs came into picture, where you have trained your model on large data sets and you've built large models, right? And these models can actually understand various topics that you're familiar with, right? So that's the large part here. And the second part is language, right? Why did language come into picture? Now, obviously, you are all familiar with the chat prompts. So whenever you ask some questions, you're actually asking in some natural language. So the model first needs to understand what that query is, right? So in order to understand the query, it has to basically know the language models. So all your chat based are all first primarily a language based models, and then the language is converted into an output, and that output is given to some other ML model, and from that you derive the output. The output is again given back to the language model to convert it into a text format, and then it is given to the user. So that's where these language models come into picture, right? So now this is a brief idea about what LLMs are. So all of you might be familiar with some of the companies, leading companies that have built their own LLMs. Like for example, Google has its own Gemini model. OpenAI has its own ChatGPT model. Facebook has its model. So all these models have been trained on large data sets, and they've exposed those models to users in order to help them build their task, right? To automate their task, or to help them understand better and also answer their queries instead of like just searching in the internet, right? That's the whole idea behind building these LLMs. Okay, so now today's topic is more about understanding what are agents, right? And how are agents different from your traditional chatbots, right? And what is the primary difference between a chatbot and an AI agent, right? So we'll start with that. So before the agents came into picture, all of you would have seen this chatbot everywhere on the website, right? For example, if you wanted to book a cylinder on WhatsApp, or if you wanted to ask some query on a banking website, right? You'd always been welcomed with a standard chatbot, right? So what is the difference between a chatbot and a AI agent? So the chatbot is, think of a chatbot primarily like a if-else loop, right? So if you're familiar with the basic concepts of programming, so if the user has asked something, then the response for that will be this, right? So there is no intelligence there. So for example, if you are familiar with the IVR calls that all of us would have heard about, if you're raising a ticket on internet failure or something like that, you'll say press 1 for this, press 2 for this, press 3 for this. So the system is already familiar with what the user is giving, right? So you'll always press 1. So when the user presses 1, the backend knows, okay, when you press 1, this is the data that you have to show. When you press 2, this is the data that you have to show. So it's basically like a if-else condition. If the user has pressed this, then do this. If the user has pressed this, then do this, right? That is how it has been before. Now, with the help of LLMs, what you can actually do is understand the query, and then respond to that query based in a similar natural language response, right? For example, I think all of you also are familiar with something like Alexa and Siri, or Google's chat, right? So if you say, hey Google, so it will probably respond back to hi. If you say hi Alexa, it will probably respond back to you saying hi. Similarly, if you ask ChatGPT or any other prompt, if you ask something in natural language, it will probably respond back in natural language, right? So it is able to understand your context and then give you reply back. So when I said, hey Google, my phone, Google got triggered, and then it's trying to respond back. So it will try to respond back in a natural language process, and then it will start processing other kinds of information that you would want to do. Okay, so how does this actually work? How does this AI agent actually work, right? So the typical flow of how an agent works is, the first one is basically your user query, right? That is something that we have just looked at. The language model that sits in the first place, the NLP, the natural language processor, which will basically take the intent of what the user has asked, right? And then once the query is taken by the system, it passes the query to something called as the LLM, right? So now all of us are familiar with the term LLM, and the LLM has multiple purposes that you define. So it can actually connect to some of the tools that you already define, or it can get information from the existing data source it has, and then give back the response to the user. Now, obviously, if you look at the layers of how this agent actually works, the first layer is the UI layer, where all of us are familiar with the chatbots, or it could be a voice, or it could be some dashboards. The second layer is basically the orchestration layer, as to which agent to be called, where to store the memory, and then how to plan in execution a task. And the third layer is basically your LLMs, right, where the models have already been trained on existing data. And then the final layer is basically your database layer, right, where the resultant information is stored in the database. Now, let us look at one simple example before we move forward, as to understand where this particular agentic solutions can be applied. Like, for example, if you say LLM host, LLM client, and all those things, let's look at some practical example of where this particular agentic AI can come into picture. Okay, now a quick query here. Did you all hear about something called as APIs? The term API, is everyone familiar with this term called API? Okay, so let us just understand where this agentic interface actually makes sense, right? Where do we actually use when everyone is talking about agents? Let's just try to understand based on a simple example. Okay. Okay, so let me just go back to the whiteboard. Okay, so all of you, let's say, are like in the college, you would probably want to application program interface, right? So let's say in your college, you would want to expose some data to the outside world, right? So, like, for example, let's say there are some entities that would want to understand how many students are there in your college, how many faculty are there in a college, what is the work that is being done, right? So you probably build a backend with a lot of functions, right? So let's say get students, right? So this is one function that is there. Let's say get students, get faculty, right? And then you probably have other functions that are exposed to the outside world, saying that, let's say, get patents, get publications, right? So this is the data that you have exposed to the outside world. So these are all, let's say, the APIs that your college has exposed to the outside world. Now, if someone has to interact or find out how many students are there in your class, so if I'm building some website, so I would have to know what this particular application is. For this, I have to know what is the syntax of this, and then make a call to this request to get the data. Similarly, if I have to get the publications, I would probably have to write some function to get the publications. And similarly, if I have to get the number of faculties and other information, I need to know what these APIs are, and then get that particular information, right? So I need to know, basically, what do I need to know? I need to know how to code, right? So this guy who's sitting on outside of your college needs to know how to code so that he can write request, write request, and then fetch information from your college, right? So what has happened with the help of agents? Now this guy doesn't need to code, right? All he can do is just ask. Let's say he'll just say, get me students, right? So you'll just say, get me students. Now, obviously, your computer or your programs will not understand what this query is, get me students. So what the agents will do, right? With the help of agent, when you ask a query to the agent will take that query, right? The LLM will have access to your APIs, right? So when you ask, let's say, get me students in natural language in English, the agent will send that request to the LLM, right? Now the LLM already has information about all the different functions that are there. So what this does is it will convert this query. It will convert this query and then figure out what is the right API call to be made. Let's say it says get students. So it will say, oh, get students. It will understand the meaning of get students. It will go to the right query, make a call to that, get the data, and then send it back to the user in the prompt. Right? Now the student or the person who's outside your college doesn't have to write any interface or anything. You are just exposing a prompt to the user where the user can just ask something and the query is routed through the LLM. The LLM has access to your API calls, right? And then the LLM will map the query to the right API, make a call to the API, get the response, and then give it back to the user in the chat prompt. Right? So that is how a typical agent will behave. Now, why is it becoming more and more useful? Right? That is the most important part. Why did this gain a lot of traction in terms of industry? In the industry, why do you see a lot of traction happening here? Right? So one example that I can give you, and you can probably see it in the future, is I think all of you must have come across voice agents, right? So where is this voice agents typically used? Right? Where is this voice agents typically used? So voice agents have been typically used in BPOs, right? So all of you are, you know what BPOs are, right? So, okay, even before voice agents, you can probably look at customer request, customer services, right? So whenever you ask something on a chat, now it is able to understand the context from the user and then give right directions to the user. Now, coming back to the voice agent, in this example, instead of a chat based, you have voice. Right? So you ask something on the phone whenever you make a customer request, whenever you make a call to, let's say, your internet operator saying that your internet is not working, you will hardly find any humans now using behind the phone, right? You'll see a voice agent that will understand what the user has asked. It is able to decode the problem from the user. It already has a lot of information about the data that is there about the user. It has data about the problem and about the solution. So it will make a call to the LLM. The LLM will fetch all the information, all the required information, and then it will just convert it into another voice and then give back the response to the user. Right? So how is this being used by different companies? So one such example is customer care. Right? So if you look at customer care centers, the first adoption of agents actually started with the customer care request. So whenever a user is actually asking for any request saying that, okay, let's say your internet is not working, then it will first check whether the network connectivity is down, if there's some problem with the network provider, and then it is able to resolve or at least raise a ticket based on a human operator. So what is the advantage here? So the advantage is you're not dependent on a human person, and this agent is now available 24/7. Right? So with that kind of automation, you will see that a lot of queries are being resolved faster, right? And then you'll also see that customer is happy because a ticket is raised and then the ticket can be resolved at a faster pace. Okay, I'll just take a quick pause. Any quick queries so far? Anything that you didn't understand? Anything that is something that I can repeat? Any quick questions? Any quick queries so far? Okay. Okay, so now just going back to the earlier idea behind where agents fit. So now we see that again, the first is the chatbots or the voice. We talked about customer care, customer requests. Then you have the agentic layer, and then you have the model layer, and then you have the data layer. Now, why do we call this as the agentic layer? Right? So we saw the model layer, but what is this agentic layer? So the agent is not just about one aspect of development. So the agent can perform multiple tasks, right? It can fetch information from the internet, get the information from the internet, pass that information to the LLMs as input. It can take the input from the user, process it, understand it, pass that to the LLMs. It can also probably make some other request to some other tools, get the data from those tools, and then again pass that as information to the LLMs, right? So the agent, you can think of it like a multitasking software that is able to do multiple tasks and then summarize all that information into one and then give it as input to the LLMs. Okay, so now you will see a lot of competition being happening with different companies, right? So you will see that, okay, OpenAI has released one model, and then all of a sudden you'll see Gemini next version being coming in. Then you'll see Claude coming up with a new model, right? So every company comes up with their own models, right? And probably you'll see also Grok coming in from Elon Musk, right? So what are these different models? Why are people coming up with different models? First and foremost, the most important thing is speed, right? Second most important thing is the accuracy, right? How accurate the output is, right? You will see that most of the models that have been developed recently, they've gained traction primarily because they were able to write code, right? So when OpenAI came up with this tool called Cursor, right, which was using the OpenAI models, you'll see a lot of code being generated, right? So how was it able to generate code? Because this OpenAI model has access to something called as GitHub. GitHub is a repository where all the code is present. So now because it has learned a lot on that code, whenever you ask it to write or generate a particular task, it is able to create a simple app within seconds, right? So let me just show you a small demo of how this particular thing actually works. Just give me 1 second. Okay, so now what you see on my screen is basically the app that I was talking about, which is called cursor. Okay, so cursor is basically written on top of VS Code. VS Code is an editor, right? So now you will see that this is like a simple terminal where you can write the code. Let's say you want to write code, right? So you'll probably write the code like this. Right? This is what we used to write earlier. But now every editor has come up with something like a chat prompt, right? So if you write chat, you see the chat prompt here. It is automatically connected to the LLM, right? So now let's say you want to write code for printing even numbers. Okay, so now you see something called planning, right? So basically the model is trying to plan the action, like what it is supposed to write, right? And then you can actually see the planning there. Okay, so if you see here, this is the steps that it has done, right? So first it has planned on how to actually write the code, right? And then it will start writing the code. So how does it know that it has to write the code? Because it has already has access to this model of ChatGPT has already been trained on code that is available on GitHub, right? And based on that knowledge, it is able to generate this code. So you see that it has generated the function to print even numbers, first even numbers, right? And then you'll see all the code being written within seconds, right? So what is the query that I've asked? The query is write a code to print even numbers, right? So when the query is asked, agent picks it up first, and then it will try to understand, put a plan on how to actually go about solving this question. And then step by step, it will try to execute those things. Like for example, say, okay, let me write a function, print even numbers. Let me write this function, first even numbers. Let me write this. And then how do you compile this, right? So with this, actually it picked up pace, right? When people started to see the benefit of writing code, people started to understand how powerful the agents can actually become, right? So that was the power of agents. So that's how people started incubating agents into their systems. Now, once coding became popular, people started using it with various sources of information, right? So one such source of information is something that you already again would have been familiar with, which is let's say the Ghibli art, right? Over the last probably couple of months back, everyone would have experimented with this Ghibli art. So how did the OpenAI come up with building that Ghibli art? So it had access to all the Ghibli art images. It has trained a model on that particular data. And then when you ask the query to generate your image on top of, based on that particular style, so it was able to do that, right? So now let's go back to the important part is speed and cost. That is something that we've seen. So reasoning models is something that is understood. Now, when you dig deep a little more into what are the parts that an agent consists of, right? So there are 4 different parts that you can always think of when you're designing an agent. First, the brain, which is obviously the LLM, which will tell you what to do. Second is the plan. Third is the tool. And fourth is the memory. So these are the parts that we've already been talking about again and again. What to do, and then how to do it, and then what are the tools that you can use in order to perform that particular task, and then memory. So memory, why do you need memory? Because you have to maintain context. If you've asked some question upfront and then you're asking a follow-up question on it, so the prompt needs to understand, okay, what happened previously, and then give you result based on the historical data, right? So these are the 4 steps that are required in order to build an agent, right? Now, whenever we are actually building agents, we actually call something called as the React tool, a React loop, right? This is something that this is a common terminology that we always think of. So what does React mean? React means reason plus acting. So that's the fundamental concept of any agentic behavior. So whenever user asks something, you will think, and then you will reason out, and then you perform any action, right? For example, when you ask, okay, what is the temperature today in Hyderabad, right? So now, how does the prompt know what is the temperature in Hyderabad, right? So it needs some tools. So first thing is it has to understand what the query is. Second, what are the tools that are required to answer that particular query? So when you say what is the temperature today in Hyderabad, it will probably look for all the weather sites that are available and that it has access to, and then perform a query to that particular tool. Let's say there is some weather API that the government of India is exposing. It will make a query and then get back the answer from that and then give you the result. Okay, that is one way of solving it. Or let's say get me the I think recently, let's say the government of Telangana has announced what is the let's say 10th class details, right? So when are the 10th class exams starting, or when is the board of intermediate exam starting, or when is the MSET being scheduled for 2026? If you ask such a query, then how is the agent able to answer that particular query, right? First, understand what that query is, and then check for any available sources of information that is available on the internet, and then make a request to that particular query and then give the information. So when you say, okay, when is the MSET being scheduled for 2026, it'll do a search on the websites that are available. It'll probably hit the Board of Intermediate website, scroll the Board of Intermediate website for the relevant information, process that information, and then give it back to the user, right? So now you keep on doing this again and again, follow-up questions to the user. Okay. Now the most important part here for agentic behavior is it is not just one iteration of information, right? When you build complex agent with all these 4 steps, you can also have something like whether the information that it has procured is correct or not, right? Whether the information that the first agent has given is actually correct or not. So you can actually write a loop that goes on, and then when there is a satisfying output, and then only it will give back the output to the user. So that is some behavior that you can actually incorporate instead of just giving one sentence answer. Like for example, if you go back to the models of how GPTs have evolved, so you have something called as flash models, right? So these flash models does not do multiple loops. They'll probably limit their loops to 1 or 2 or maybe 3, and then give back the answer to the user. So that will give you a feel that, okay, these models are really fast. But when you go back to the complex models, they'll run these reasoning loops multiple times to make sure that the answer that they're giving to the user are actually valid and correct, and then give back the result to the user. Okay. Now, when you talk about tools, right? So what are the different tools that these agents can access or these LLMs can access? One, like I said, it's the common information that is already available on the internet that these LLMs can access. The second kind of tools that these LLMs access could be your own databases, right? So generally in a company or a college would probably store all the information in a particular database server. So your LLMs can talk to the database server, make a query, get the response, and then give it back to the user. So let's take one example of let's take the example of a college, right? Now all the students database, all the students information is all stored in a database or in an Excel file. Let's assume that these are all records that are stored in Excel files or in some database, right? Now, if you want to access a particular student's information, right, and that student has, let's say, passed out 10 years back from the college, how do you fetch that information? Right, that's the query that we want to solve. So you want to fetch the student information that is available with you, but it is actually 10-year-old data, right? Had it been physical copy, you would probably go over the records, go to that particular area, let's say 2015, look at the department, look at the roll number, go to that particular roll number, and then fetch the details of that particular student. Now, if it is stored in some Excel file, what you would have done probably is go to that particular folder where that particular student is there, take a record, and then give that details to the user. Now, with agents in place, you don't have to access the data at all. You'll have one layer where you can just like provide a prompt, and based on the prompt, this particular LLM will have access to your data, and then it will directly understand the data, give the particular student response, give the student details as a response to the user, right? Think of it like even in a database, you have to write a query to fetch the data from the database. The LLM itself will write the query, fetch the data, and then give back the response, right? So these are the tools that the LLM will use. So when we say tools are basically the action, right? The agent will select what is the right tool and then get the response from the tool. Okay, quick break here. Any quick queries, any quick questions so far? Any doubts or anything that you have missed understanding? Okay. Okay, so the reason why I'm explaining all this is like probably in the next 15-20 minutes, this is what we're going to build, right? So we're trying to probably build a tool, we're trying to understand or write a query and then get back the response, right? That's something that we're going to do. Okay, so now the third part in this particular, the fourth part after the tools is basically the memory, right? So you have the LLM, right? So how do you get the LLM? LLM is available on the internet. You can use OpenAI models, Google Gemini's models, or any other model. The model will already do the planning. You actually give these tools as input to these LLMs, and then the output needs to be saved somewhere, right? So where does this memory sit in, right? So when you talk about memory, there are two kinds of memories. One is the short-term memory, and the second is basically a long-term memory. Right. So what is a short-term memory? This is like your RAM in a computer, right? So whenever you restart, the entire data on the RAM gets wiped out. So similarly, the short-term memory is like the contextual memory on the chat. So when you close the chat, all the responses, all the questions in that particular chat gets erased, and there's no context of it remaining. The long-term memory is basically when you want to store that information in your database. So there are different kinds of databases where you can store. So basically the kind of databases that are used is called vector database, right? So all this information can be stored into a database, and when you come back, that information is already present. Now, one example again you can relate to is let's say all of you are working on ChatGPT. So when you close the session, terminate the session, and then come back, you will see a historical record of all the chat, all the prompts that you already have created, right? So that information is also there. So where is that information getting stored? That information gets stored in their servers, the database servers of OpenAI, right? So that is a long-term memory. Now, when you actually ask a question, like for example, when you start a new chat on your prompt, you will see that it will try to relate to what you've asked before and try to give you information based on that as well, right? So probably if you would have come across this use case where it will ask you whether it has to take the context into picture or not, right? If you say yes, then it will read through all your historical prompts, and based on those prompts, it will try to fine tune the answer to you, personalize the message to you, and then give the answer back to the user. Okay, now, so far we've all been talking about what is an agent, how do we, what does an agent do, how does it do, but then what are the actual tools that are required to build these agent, right? So one such tool that we will use is called LangChain, right? So LangChain is basically a tool or an orchestrator that will help you to build an agent, right? And then through LangChain, you can actually invoke the LLM, use the LLM output, provide input tools to the LLMs. If needed, provide the interface to the memory, right? And then integrated with, it is already integrated with a lot of pre-built wrappers like Wikipedia and other things, right? And then you can also add multiple agents to it, do some kind of agent orchestration, and then give you the output, right? So this is something that LangChain has already built. So it's a company like OpenAI, which is specialized in building agents and agent orchestration, right? So in our example, we're going to use LangChain to actually build a small agent. That is what we're going to do. Okay, so let's take a quick 2-minute break. I will just share the links for building the code, so that all of us can actually do this together. So if you're on your laptops, I think I'll encourage you to open Google Colab. I'll share the link with you also. That will help you to build the small code required for agent development, right? So just give me 2 minutes. I'll just do the setup and then get back to you. Until then, if there are any quick queries, any doubts, any points that you've not understood, feel free to put it into the chat. I will try to answer it on the chat or probably during the session. So we're going to run the experiment on in Google Colab. Okay, so the link to, so Google Colab, I think most of you should be familiar with the Google Colab. I've put the link in the chat, so all of you can just click on the link. You'll see an option called New Notebook at the bottom. Just create a new notebook.
Sir, please kindly share the screen, sir.
Yes, I haven't shared the screen. Just give me a minute. I'm just sharing.
Yes,
Screen
sir.
is not shared. I'll just share it in a minute.
Okay, sir. Okay.
Just give me 1 minute. I'll share.
Sir, sir, Anirudh sir,
Yeah.
are you there?
Yes, I'm there. Yeah.
Yes.
So I'm just waiting for any questions or anything like that. So I haven't I just waited. So I haven't.
Participants, if you have any queries, kindly post it in
Yeah.
chat box. Sir, only 10 minutes, 20 minutes more, sir.
Yeah, it will not take. The code doesn't take much time.
Okay, sir.
Yeah.
Right. Proceed.
Okay. So let's begin. Okay, let me share the screen. Okay, so when you open the collab.research.google.com, you'll be prompted with a pop-up that says open notebook. At the bottom, you'll see something called as a new notebook. Right? So if you don't see anything like that, just click on cancel at the bottom. Right? If you click cancel, you'll see something like this. Okay, so what is Collab? Collab is basically an online editor tool. Like for example, your Google Word, Google Doc, Google Excel, Google Spreadsheet, right? All these are online cloud-based document tools, right? So similarly, Collab is basically a online code execution, right? If you want to create new code, then you want to run code on a remote server. This is basically used for that. So let's create a new file. Just click on new notebook in Drive. File, click on file, and then you have new notebook in Drive. I'll just explain. Once you click on that link that I have shared, close the pop-up. You'll see this page here. You'll see an option called file, and then you have something called as new notebook in Drive. Okay, so once you click on new notebook in Drive, it will open a different tab, and then you'll be prompted with a prompt or a cell, right? So earlier when AI and all those things were not there, the GPTs were not there, people started writing code here. Like for example, if I have to print something here, print hello, right? And you see the play icon here, you click on the play icon. Okay, too many sessions are there. Let me just close something. Just hold on for a minute to just come. It's still connected. So if you see print hello, you'll see the hello icon, hello being printed. Okay, so this is the simple code here. Now, the idea is not to learn this part. The idea is to write the code for agent, right? So we'll just do a simple example here. Let's say you want to find out, let's say write some name for the company, right? That is something that we want to do. Okay, so the first step that we will do is every company will give you something called as API keys, right? So we talked about how do we actually talk to LLMs, right? How do we talk to LLMs? Now, I'll show you one example for OpenAI, right? So when you open this URL called platform.openai.api keys, so you have multiple API keys that you can create, right? What is this API key? So API key will enable you to talk to their LLMs, right? This is an API key for talking to OpenAI models. Similarly, Google will have its own API key to talk to Gemini models. Similarly, Grok will have its own API key. For Claude will have its own API key. I will share the API key for you all to work with right now. Right? So don't get confused with this particular URL. This is not required as of now, but I'm just for the sake of information, I'm telling you that how do we know which agent or which LLM to connect to? Right? That is the first part. So you can create an API key here on their platform and then use that particular API key. So I will share this probably at the end of the session so that you don't get confused now, right? Okay, so now we'll start with the first line of code telling the prompt that which API key to use. So now let me put it in the chat. So just copy paste this piece of code. Right? Okay. Once you copy this, click on the play icon. You will see the first line of code is basically installing the dependencies, which is nothing but the LangChain. Like I said, LangChain is the agentic platform that we're going to use to build the agent. Right? The second step is to feed the information of the API key. I'll just take a minute. So all of you should be getting this input called enter your OpenAI Open API key. Okay. Now, what is this API key? So let me share that API key with you. Just give me one second. Let me try it out first and then, okay. So I've shared the API key with you. Copy that and then paste it into the prompt. Copy the API key and then paste it into the prompt. You will see that dependency is installed and API key is set. Just take a pause here so that everyone can finish off here. So far, we have not done anything. All we have tried to do is install the libraries for LangChain in Python and then set the OpenAPI key. If you're using the Gemini key, you will set the Gemini key. If you're using Claude, you'll set Claude's key, right? Okay. Now, once the API key is set, just one piece of code. The API key, you will get a prompt, right? After this, enter your open API key, you will see a rectangular box to give input. Okay, let me run it again. For those who are still figuring out where to insert the API key, I'll just run the cell again. Okay, so once you run the above code, oh, okay, I think this is, let me delete this. It is already set, so that's the reason why it is not asking. Yeah. So you will see that there's a rectangular box that comes in. You probably have to enter there. Okay. Let me just continue. For the others, maybe I'll do it again, second time. So for those who have done, let's just continue. So you've set the API key so far, right? Now is just one piece of code that we're going to run. So just copy these 5 steps or the 6 steps. Okay. Copy one after the other. So did you all copy the 6 points? Just put it into one prompt. Okay. It's step 2, getting error. Okay, what is the step 2? Okay, so you have to run everything together. Okay, wait, just 1 second. Oh, line 2. Okay, so actually it runs together. Let me just run it. Okay, let's do one thing. I think let's just do it one by one. Maybe if that is difficult, let's just do it step by step, one by step one. Okay, so it actually works. Okay, don't worry. So let's do it step by step. Okay. Okay, first step, let's import the LangChain components. Can everyone do this? Import all the LangChain components. Okay. Now let's do step
Dear
1.
participants, kindly mute your Harita Tumala.
Right. So the first step is importing all the required libraries from LangChain. We've installed LangChain, if you remember, first. Then the second step is to import them. Now the third step here in this case is use the model, right? So we are specifying the model here. So if you see the model is GPT 3.5 Turbo. So you'll know that there are different kinds of models, right? GPT 4.0, GPT 5.0. So now we are specifically saying use this particular model called GPT 3.5 Turbo. Okay. Then the next step is to define the prompt. What is the prompt? You're telling the system or the agent saying what you are, right? You're saying you are a creative naming agent. Your response must be short and witty. User is basically the query. Whatever we give in the chat, we're basically hard coding that particular question here. Suggest 3 innovative names for a company that makes a particular product, right? So this is the prompt. So whatever input that you give in the chat is what is the user saying, right? For simplicity's sake, we are just putting it in, hard coding it into the prompt. But you can actually connect it to a chatbot. Whatever input comes from the chatbot, you can give it as an input from the user. Okay, so the prompt is defined. Okay, now once the prompt is defined, the output of that particular prompt, should also be a proper natural language response, right? So that is taken care by the output parser. Whatever output comes from the LLM should be fine-tuned as a natural language output. So that is taken care by the output parser, right? And then we define the chain. I told you the agent chain, right? So what is the agent chain? First is the prompt. Prompt goes to the LLM. LLM gives the output to the output parser, right? These are the 3 steps. So the 4th step is not involved. If you remember, the 4th step is the memory. So the memory is something that we are not including. So what is prompt here? Prompt is nothing but your system prompt and the user prompt, what the user is giving. System is basically telling what that particular agent is. The second is the LLM. What is the LLM here? You are using the GPT 3.5 model. Then the output. So it's like a pipeline, right? If you remember the presentation, first user prompt is given to the LLM output is given to the output parser, right? This is the next step. Okay. So now you define the chain. Let us define the output. So if you look at the input here, if you look at the input, right, we did not define what product you want to give a name for, right? So this product is what we are giving here. What is the product name? Product name is AI powered coffee mugs. This is the product name. So what is the output that we want? Suggest 3 innovative names for a company that makes a particular product. What is the product that we are giving as input? AI powered coffee mugs. So what we are trying to ask the prompt or the GPT is, give me some names of a company or give me the names of a product which does AI powered coffee mugs. Okay, this is the input data. So response will be chain.invoke input data. So input data is nothing but this product. So when you call this invoke, what gets triggered? This chain, right? What is this chain? Taking the prompt. So this product is replaced with AI powered coffee mugs. This goes to the LLM. LLM will give you the output. Output is parsed and then you get the response. So invoking chain. What are the new names that it suggested? Brewbot mugs, Smart Sipware, Java Genius cups. Right? Now, you will see that you mentioned 3 here. That is the reason why it has given 3. Right? You can try this out with some weird queries. So the last line I'll just put here. You can also invoke, let's say a product is fast moving speed shoes, something like this, some random product that you want to build. Let's see what is the response that AI will give. So it does give velocity, stride, turbo threads, rapid soles, and so on. Right? So you can also change the system. What is a prompt that you want to build and ask a query based on that. So whenever you're building an agent, the system prompt is the most important thing, right? So we can probably, let's say you're a creative teaching assistant, right? Help students answer query in Python. Okay. So we're telling the agent that you are a creative teaching assistant. Your response must be short and witty. Help students answer queries in Python. Okay. So let's say suggest 3. Okay. We'll just write the definition here. Suggest explain. Let's just say explain. Okay. Explain. Just instead of product, I'll just explain concept. Okay. So what is the concept? Let's say loops. So all I'm trying to, just let's say I'm trying to do this. So you're a creative teaching assistant. Your response must be short and witty. Help student answer queries in Python, right? Okay. So let's run this. Chain. And then product. Okay. This is actually concept. Okay. So now, Okay, so now what is the product that okay, I'll just change this output. What is the concept that I've given? I've given as loops. So now you see the output for this particular query. Loops are like a never-ending cycle of your favorite song on repeat, but in Python. They help you do the same task over and over without getting tired. Right? So this is the answer that it's a witty response that the prompt has given. So you're basically telling the system what the system is, what the agent is, and then you're basically asking a query based on this particular topic. So now you can probably say, like, I'll just say this is concept suggested explanation. Okay, so let's say I'll remove this, let's say objects, right? See? Now, what is the answer it has given? Objects are like people, they have characteristics and methods. Just like how a person has name, age, and can walk or talk, an object in Python can have data and perform actions. So think of objects as the cool kids in Python who can do stuff and have their own unique traits, right? So this is the response that the agent has given. So the agent or the LLM would have given some other response, but it will probably, the output parser will actually fine tune it to give you a witty response and then show it as the output, right? So whatever input you give in the chat is the value that this user is taking, and whatever response that you see in the chat is the output response that comes out from here. Is this clear so far? Any quick questions or doubts on this?
Participants?
Yeah, so that's a very interesting point. Why is it given same names? So if you actually see the comment that is given here, right? Low temperature for predictable output, right? Now, if you change the temperature to a different value, let's say you put the temperature to 5 or something, you will see different outputs, right? So temperature is a parameter that is making sure that whenever you run it again and again, it maintains the output same, right? So in sometimes it is important that you get the same response again and again, right? So that's where this temperature parameter comes into picture. It is not like you type something today, it gives you one response. Tomorrow you type something, it gives you a different response, right? So that's like predictability of a query, right? You ask the same query again and again, it should actually give you the same answer again and again. Yeah, 0 means it will always give you same. Anything other than 0, it will keep changing. Okay, so just to do a quick recap of what we've done so far, the most important thing or the most important takeaway from this exercise is, in order to build an agent, right, you don't need to know a lot of technical skills like coding skills, right? All we have written is just 4 or 5 lines of code to build an agent, right? What is more important is to think of what kind of use cases you can solve with the help of agents. So how can you automate the work that you're doing, right? Agents can be used to, let's say, write a blog every day, right? So let's say you're teaching AI and every day you want to post something to the students. There's a WhatsApp group, and then every day you want to say, you want to send a message to all the students based on the recent topic, right? So you can actually build these agents that will fetch data from the internet, push it out into the WhatsApp group, right? That is some kind of automation that you can do with the help of agents. So the most important part is, what kind of applications can you think of that will use the benefit of these agents and then make your task easier. Okay, so like I said, the most important aspect is identifying the problem that you can solve with the help of agents. So I've been giving some examples like voice-based agents, right? Automation agents in factories. You can see, let's say, ticket creation, automatic ticket creation when something wrong happens, incident tracking, incident creating, right? All these are automation tasks, and wherever human response is required, you can always take the human response, a voice-based input, and then convert it into a required task, right? That is something that you can always live. But someone who's really interested in how to learn this better, I would definitely suggest you to do voice agents. Like for example, like Alexa, try creating something like Alexa. Like for example, on your laptop, you want to fetch a particular document, right? And you don't know where that document is. You'll probably search it in the folder. You can say, let's say, use a voice agent saying, get me this particular document, right? Or in Google Drive, you don't know where that photo is. Write an agent that says, okay, get me a photo with this particular person in Google Drive. Right? It could be a chat-based thing also, or it could even be a voice-based application. Right? So building agents is not a big deal, but what is a problem that you're trying to solve is the most important thing.
Okay, sir.
Yeah.
Yes.
Okay, I think with that we'll probably end the session. Any questions? Probably you can just
Any queries?
Put it in the chat, or else reach out to me later.
Okay. So good evening to everyone present over here. On behalf of our management, coordinators, and all the participants, I am delighted to deliver the vote of thanks to for today's session. So first, I extend my sincere gratitude to our esteemed resource person for conducting truly enriching hands-on session on agents LLMs. Your practical demonstration, step-by-step guidance, and clear explanation have given our participants a strong understanding. So thank you, sir. Thank you, sir, for hands-on session and giving introduction to agents and recent development on LLMs, LangChain, building simple agents on hands-on. Thank you, sir. Andu, sir.
Thank you, ma'am. I think thanks for the opportunity.
Yes, sir. Thank you, sir. We look forward to more such learning opportunities in future also. Thank you, sir.
Absolutely. Yeah, thank you.
Thank you, participants, for your patience. Today, 10 minutes extended the session. So kindly excuse me. Thank you, one and all. I think you have filled the Google form feedback link. Thank you, one and all. Thank you, sir.